Welcome to the Canary Systems MLGPS 2.0 webinar. My name is Dave Nelson. I'm the support manager, and I will be presenting today's webinar. Amanda Senecal will be hosting with me, and our subject matter expert, Alexei Suvrov, will also be joining us in case any technical questions come up with which I need help. During the presentation, you will be muted. However, we encourage you to submit any questions you may have through the Zoom chat. The agenda for today's webinar. We'll start with an overview of Canary Systems MLGPS, specs and features of both versions of MLGPS 1 and 2. We'll then go on to what's new with MLGPS 2.0, some modifications to the Canary Systems Multi-Logger 2019 software to support offline mode. And then we're going to wrap up with a couple of demos. One that will simulate offline data collection after a connectivity failure. And the second would be a manual transfer of data from the SD card into the multi-logger software. So we have a base system set up as a demo unit at our New Hampshire office, and we thought we would show you a video of that unit so you can get a sense for what it actually looks like. Here you can see this is the entire system. First we'll focus on the GPS antenna. It's a Novatel antenna. It's mounted on a well casing and it's wired underground over to the rest of the system, which is mounted on this pole here. And you can see it comes with a solar panel. It has a Wi-Fi directional antenna that you can see at the top of the pole. And then here's the enclosure. We'll be opening that up in a minute. It's got, B1 stands for base 1. So this is configured as a base. This is the actual GPS unit. You can see the LED lights on the panel. They tell you whether it has power, what status of the GPS, status of charging, etc. And then here are the lead acid batteries that ship with the unit. And that is the entire turnkey system. To set the foundation for the rest of this webinar, I want to spend a few minutes reviewing the specifications and features of Canary Systems MLGPS. There have been 2 hardware releases of MLGPS, version 1 and now most recently version 2. We'll get into the differences in a few minutes. MLGPS is a turnkey system. So it integrates a multifunction GPS module along with power control, battery charging, and communications platform specifically designed for geotechnical and structural monitoring applications. MLGPS can leverage the built-in wireless module or can be deployed using an optional cell modem for connectivity, depending on the availability of communications options at the site. MLGPS is a differential system, meaning that there needs to be at least one base station on a stable known point to act as a reference for multiple rover stations, which are attached to structures you intend to monitor. The base is used to determine an atmospheric correction that will be used when calculating the position or solution for each of the rovers. It's critical that the base is stable and the exact position is known. Bases use the same MLGPS hardware as rovers, so there's no difference in terms of the hardware components. It's the difference is in how it's configured within the multi-logger software. And since the atmospheric correction is assumed to be the same between bases and rovers, it's also important that all rovers leveraging a given base are deployed within 6 miles of that base. We call the measurement of the MLGPS unit for a given time period a solution. And the longer the solution, the better the average precision. So for example, a 15-minute solution produces a 25 millimeter average precision, while a 24-hour solution produces a 2.5 millimeter average precision. The Canary MLGPS also can receive data from both the American GPS L1 and the Russian GLONASS L1 constellations. There is an optional upgrade to support more constellations. So what is new in Canary Systems MLGPS 2.0? The first change is that we've upgraded the integrated Wi-Fi Ethernet adapter and are now using a Lantronix XPico model. The main driver for this change is the improved wireless range of the XPico, up to 1 mile with a directional antenna. The big change is that we have added an SD card slot to the MLGPS module, and the system now ships with a 32 gigabyte SD card. This card can hold over 1,200 days of raw MLGPS data. To my knowledge, Canary Systems MLGPS is the only GPS unit in our industry that has an onboard storage. You might ask, why is onboard storage so important? Well, by adding this onboard storage, we can significantly improve the quality and reliability of the GPS data. Without the onboard storage, the system is at the mercy of the connectivity between the MLGPS unit and the server running multilogger. If there's a break in this communication, for example, a wireless access point failure, general poor wireless network connectivity, a server issue, or if a server is being rebooted, for example, for OS patching, the data collected by the GPS unit during that outage is lost. With the addition of the onboard storage, we have removed any dependency on network connectivity, as all raw data is written directly to the onboard storage. A copy of this raw data is retrieved by the server when network connectivity is reestablished. With this onboard storage, it's even possible to use MLGPS to monitor structures in areas that have no connectivity options, no network, no cell service, for example. Data can be written to the onboard storage, and the SD card can be manually retrieved at periodic intervals, swapping in a new SD card for continued data collection. And the data that has been collected on the SD card can be consumed by multilogger right from the SD card. We're going to show as part of the second demo how that will work. The other big benefit of onboard storage is that the XPico integrated network interface module can be powered off for specific intervals to save power while GPS raw data is being written to the SD card. When the XPico module is powered on, all data since the last data collection will be transferred to the server. Once all data is collected, the XPico can be shut off. This is a great solution where power consumption is a concern. Shown here is a detailed picture of the MLGPS 2.0 module. We wanted to show you the particular
ports that are available or the particular components of this card. And I'll just point out a couple here. One is in the lower left-hand corner, you can see the micro SD slot. There is also an eject button next to that. It's important to use this eject button when you are pulling out the card as opposed to just popping the card out. The Wi-Fi RS-232 port is used to configure the XPico wireless module, integrated wireless module. The GPS RS-232 is an RS-232 port directly to the GPS receiver. And then along the side here, you have an Ethernet port, and the two antennas connect there.
The final step before we get to the demos, I want to show you some of the changes that have been implemented in the multi-logger software to support the addition of onboard storage in MLGPS 2.0. For those of you who are not familiar with multi-logger, it is a Canary Systems software application used to configure and manage data acquisition equipment, including MLGPS. Since this webinar is focused on MLGPS 2.0, I will limit discussion of multi-logger to just MLGPS configuration and monitoring. What you're looking at on the screen is the logger, what we call the logger form, or the configuration area for an MLGPS unit. And in this case, you can see the station name in the top left-hand corner is GPS-R1. There's on the top right-hand corner, a status in green here, and it says offline, which simply means that that multi-logger has recognized that there is an SD card inserted in the MLGPS module, and that it is writing data to that card. If there was no card in the module, the system would work just fine. This would say online, and it would bypass writing data to that card. If you remember earlier, we discussed the fact that the hardware is exactly the same, whether it's a base or a rover, and that the differentiation happened in the multi-logger software, and this is where that takes place. So in this case, this station type is a rover, but there is the option to make it a base as well. This section, offline mode, is new, again to support the onboard storage. And so we discussed the power saving option of being able to turn off the XPico onboard Wi-Fi module. And this is where you would do that. So this radio power on interval, it's currently set to 5 minutes. You have options here. We can set it to always on, or leave it at 5 minutes. The radio power on offset in seconds is the amount of seconds that the radio should turn on prior to whatever radio power interval you set. So at 8 seconds before a 5-minute interval, it's going to turn on the XPico module so that it's ready to transmit data at exactly the 5-minute mark. And then the radio idle in minutes, in this case it's set to 1, is how many minutes the radio will stay on after there's no activity. And then down in the bottom left-hand corner, you can see these two red icons. It looks like it's basically two plugs, and they're disconnected. So that's indicating that the unit actually is not connected right now. And then the last piece about offline mode is here. The raw date, initial date, is the date that it will start collecting data from the SD card. And I'll show you just one more on the advanced settings tab. There's a GPS data archive maximum age, and this is how many days of raw data are actually stored on the server as opposed to being stored on the SD card. So in this case, we're keeping 31 days worth of raw data on the server at all times. So those are the changes, and I think now we're ready to go ahead and perform the first demo. For this first demo, we're going to simulate the loss of connectivity between the server running multilogger and the MLGPS unit. And so we have a demo system. There are two MLGPS systems, GPS B1, which is configured as a base, and GPS R1, which is configured as a rover. So if I open the logger form for GPS B1, and I look at the solution chart, and there's just one single 60-minute solution on here, and I zoom into today, you can see that the last data point is at 2 p.m. on at 2 p.m. on the 30th, and the time is 6:15 p.m. So we're missing 3, 4, 5, and 6 hour data points here. And the way that we're simulating the network connectivity loss is that I actually just pause this base. And given that this is a differential system, we're going to open up the R1 form as well, and look at those solution charts. And we'll do the same thing and look at just this has 3 solutions, but let's just look at the 60-minute solution here. And we'll zoom in to today, and that also, so this system is actually still collecting data. It's online, it's got raw data, but it can't create solutions because the base can't create solutions for it to use. So going back into B1, I'm just going to go ahead and hit the start button here to simulate that the network connectivity is now restored. And because it's in a 5-minute interval, it means that the network card is not currently on, so it can't upload the program even though the network is now available. So I'm going to say OK to this, and it's going to tell me, okay, it's essentially I couldn't talk to the data logger, but the next time I can talk to the data logger, I will push the program if you would like me to. And so I say yes to this. So notice in the bottom left-hand corner, the icon is indicating it's not connected. We have these green arrows spinning, which is showing me that there's a queued operation to be uploaded to the logger the next time it actually can communicate. And so at 6:20 p.m., the system will reconnect, upload the program, and then request a list of files to download. I'll also notice that the solution 1 is red, and if you highlight over it, it actually tells you that there's latency of 3 hours, almost 4 hours here, and that the last solution was at 1400. So that's why this bar is in red. If it was up to date and getting solutions on time, it would be green. This is also an interesting point here. This box here tells you the last time that it actually did communicate. So it was 2:15:27, so p.m. And so now we just hit the 5-minute mark. You can notice that it now shows that we're connected, and it's receiving files 3 out of 87. And when it gets enough files that it can process the next solution, the this status bar for solution 1 up here is going to change from 25% collecting to processing. I'm going to flip over to the solution chart so we can see this. So again, the last point is 2 p.m. We're collecting files. So we've gotten 4 more files. These files are 5-minute intervals of data. So notice now that it just is processing. Unfortunately, it changed my view here. But we now have a 3 p.m. data point. I'll switch to this view. So without any intervention on our part, if the network just starts back up again, or the problem that caused the network outage comes back, it will just simply self-heal, go back, collect the data that it missed, create the solutions, and move on. And so in this case, it's probably going to take, I don't know, 40 minutes or so to work through this process. I will also show you that while that's creating solutions, the rover also is getting updated. So both systems, essentially the rover knows that it needs the base's data to create a solution. As soon as the base's data is available, it knows that it has enough data to create on its own to create the solution. It matches them up and creates the solution. So we'll come back to this, but in the space of 40 minutes or so, we'll be fully caught up. These solutions will be green, and everything will be back to normal with no data loss. To summarize our first demo, we simulated a loss of connectivity between the server running multilogger and an MLGPS station. In this case, a loss of connectivity with a base unit for more than 4 hours. We observed the gap in data for both the base GPS unit and one of the rovers that relies on atmospheric correction data from the base in order to produce its own solution. We then restored connectivity to the base and observed how the system was able to collect all of the missing data stored on the new onboard storage, and without any human intervention, fill in all of the missing solutions for both the base and the rover. Without this onboard storage, there would be no way to recover this missing data, and it would be permanently lost. Again, to my knowledge, Canary Systems is the only company in our industry with this onboard storage capability built into its GPS receiver. For the second and final demo, we have a situation where we want to monitor an area using a GPS rover where there is no cell service and there is no wireless connectivity. And the only way to get the data from the GPS unit to the server is by ejecting the SD card, replacing it with a new SD card, blank SD card, and taking that SD card back to the server and importing the data into Multilogger. So in this, we're going to use the same demo system. So we have a base and a rover, and in this case, the base system has data up until the current time of on January 4th at 1 p.m. and you can see it's 1:31. So this is current. And then if I do the same thing and look at the R1 data, its solution charts has data, the most recent data is from January 2nd at 6 p.m. And to simulate this, what I had done is just pause the GPS unit so that it wouldn't collect any new data. So I've gone to the remote station and I have copied the data off the SD card, and I have the days, the 2nd, the 3rd, and the 4th, all copied to a local folder on my machine here. And all I need to do is open up Multilogger, R1, I go to maintenance, and I transfer raw files. I browse to the folder, this one here, where I have the 2nd, 3rd, and 4th, and I say OK. And I get this message that just says the new MLGP offline files will be copied to the station's raw data archive. Processing of solutions will run automatically. Do you want to continue? And I say, yes, I do. And here you can see that it's going to start copying. And it will also start processing solutions right away. As soon as it has enough data copied to produce a solution, so this is a 1-hour solution, it will start processing. So if I click over here to my solution charts, so we're still at 6 p.m. on the 2nd here. We're at 74% of this solution has been processed so far. When that produces 100% of processing, we should get a new data point. And so now we have a 7 p.m. data point on the 2nd. And this will continue processing data until all of the data has been processed into a solution and displayed here on this chart. To summarize our second demo, we simulated a situation where we wished to monitor a structure using an MLGPS unit configured as a rover. The structure is in an area where there is no connectivity option, no Wi-Fi or cell signal available. With the advent of onboard storage available in MLGPS 2.0, we're able to use the onboard storage to manually transfer the GPS raw data from the MLGPS unit to the server running Multilogger, import that raw data, and once transferred, automatically calculate solutions identifying movement of the structure that can be analyzed in Multilogger or can be imported to MLWeb for further analysis and presentation. Without onboard storage, the ability to monitor these remote structures using GPS would not be possible. This concludes the presentation portion of today's webinar. I hope you have found this presentation helpful in understanding the new features introduced in Canary Systems MLGPS 2.0. At this point, we would like to spend a few minutes answering any questions you may have.
All right, thank you very much, Dave. So we got a few questions in during the course of the webinar, so we're just going to go through those now, and you can continue to send questions in if you think of anything in the next several minutes. So the first one is, are there any issues running MLGPS 1.0 and 2.0 at the same time? Like if there is a base that's a 2.0 and a rover that's already existing that's 1.0. So Dave, can you please answer that question for us?
Sure. So as of Multi-Logger 2019 Service Pack 6, which is due out this month, there is no issue running mixed versions on the same system. There was an issue prior to Service Pack 6 related to the calculation of time and daylight savings time, but that, again, that's been resolved, and so we would just recommend that if you're going to run in a mixed mode, you're running Service Pack 6.
All right, thanks so much. So the next one we have is with the communications, is the unit connecting directly to the host computer with the MLGPS software on it? So this person, as an example, if they have it on their laptop, does their laptop have to be on and connected to the internet to receive data, or does the computer have to be connected to the unit's Wi-Fi itself? Dave, can you please answer that?
They just need to be on the same network, so there needs to be connectivity between them. The GPS is going to work. The raw data will be stored on the storage card, as we saw in the demo, and will be transferred just whenever connectivity is available. I don't know if did that answer the question?
I believe so, yes, thank you. The next one is, so is there an export option for the data? Dave, do you mind answering? Or Martin.
Martin, do you have thoughts on that one? I mean, you don't want to be dealing with the raw data. The solutions are importable into our ML web software, which is what's being shown on the screen now. And so here's the solutions that are the data that's created is here, and it could be exported from here to an Excel spreadsheet. I guess is one way to do it.
Okay, great. And what data metrics are available for visualization is the next question, which actually we're showing on the screen here. Dave, do you mind going into an explanation or?
This is 3D movement. Is that you, Martin? So what you're seeing on the screen here is 3D movement for a particular GPS solution. This happens to be a 60-minute solution. And so it has all the different components, and the movement is the aggregate of all three of the components: northing, easting, and elevation.
Okay, thanks. So I just heard from Martin that he's having some technical difficulties, so we'll keep asking questions, and if there's any that we have for him, I'll check in with him in a bit. For now, I'll move on to the next one. Let's see. So does the system monitor horizontal and vertical movement of a point on the ground or subsurface point?
So this wouldn't be subsurface. This would
I'm
be...
back. Sorry, guys.
Okay.
This is Martin. Yeah, I don't know. Zoom kicked me out. Yeah, GPS is a technology for monitoring surface points, not subsurface, because you do need to have line of sight to the satellites.
Okay, perfect. Thank you. So there's one question that I had that I missed earlier. That was, so how do you stop vandalism when it comes to this system?
Well, I mean, our station is using a NEMA-rated enclosure, which is pretty proof against vandalism. But if you do have to take additional measures like fencing or maybe you know, like our ML webcam system to observe and deter vandalism, that's of course possible as well. It's not. You would have to take additional external measures if you really have concerns about that.
Okay, thank you, Martin. So the next question is, what is the best way to show long-term that a structure is not moving more than an annual thermal cycling, i.e. for dam deformation? Can Martin or Dave, can either of you answer?
Yeah, I mean, you would see this in a long-term, in a long-range chart. Can you maybe open not this one, not the one for the base, because this one is not corrected. This is just base raw data that we're plotting here. If you open the rover, yes, this one here. Make it bigger, maybe, so we can see more data. So typically thermal cycling, obviously you will see in kind of short-term daily changes or seasonal changes, but in the system you can review data for long-term, for years. We have some installations that have been going on for years, and you clearly see trends of movement versus just kind of back and forth between the seasons. I should maybe also answer the other question that I was not able to get to in terms of visualization options and charting and so forth. Dave, of course, focused primarily on some of the new features for data capture. So we're looking mostly at the raw data, northing easting elevation in multi-logger. Of course, the system is seamlessly tied into your ML web deployment. So all the data is stored in the database as an instrument or data or in data elements. And once it's stored there, you have access to the full suite of tools that ML web offers for visualization. You can make charts, and most importantly also, or reports, most importantly also, you can create calculations. So that means that you don't have to just look at north and eastern elevation. You can use our calculation engine to calculate movements and velocities, deltas, averages, all sorts of things. Can you maybe open one of the calculations folders in the tree, Amanda? So you can see here is a whole host of calculations in the system that actually comes with the system that we've already done for various applications, velocities, inverse velocities, and so forth. And of course, others can be added as well as you need them, because you have access to the calculation engine itself. And of course, then it can be plotted, it can be reported on, and you can also create alarms and notifications based on the calculated values rather than just the raw data values. Maybe also one note, real quick, to the data we're looking at here. You'll notice we have movement here over, what is this, 6 months or so, kind of in the range of, what is this, 10, 15 millimeters roughly in the 3D movements. Yeah, and easting, northing are a little bit better. So in terms of precision that you can expect, our data is actually quite noisy. This is, they've pointed it out, this is a demo installation we have outside of our office in New Hampshire. We know it has some issues. For example, our base is fairly close to the building, so this is creating a little bit of multipath issues, meaning it's noisier than you can expect. We have some very nice installations out at several sites that have been running for a couple of years, where the data is actually better than what you're seeing here in terms of precision. And also, of course, keep in mind the precision increases with the length of your solution. So some of the data Dave was showing earlier was just either raw data or 60-minute solutions. Here we're looking at a 24-hour solution. So each point basically corresponds to 1 day of calculated, corrected data.
Great, thank you so much, Martin. So the next question we have is, does the MLGPS module track system data such as temperature and battery voltage? Dave, do you mind answering that?
Yes, it does track system data, battery voltage, charge voltages, panel temperature. It also, you can add an optional rain gauge to the system and we can track that. It tracks humidity. So yes, it does track all of those.
Great, thank you. So the next one is, can this be used to replace a slope inclinometer? Dave or Martin?
Not really, because the slope inclinometer will give you subsurface data, which the GPS won't capture. The GPS again is a surface technology, so you can see displacements and movements of a point on the ground, but not really visualize what's going on inside, because the antenna, the rover, needs to have visibility to the satellite to determine its position.
Great, thank you. And the next one is, does Canary remove outlier data in the solution set? Martin, did you want to address this one?
Yes, there are various outlier configurations in the software that are automated that you can set yourself. There's a default outlier setting which is already pretty good, but you can fine tune this to various situations, and that's already on the data capture level. And then, of course, in addition to that, we also have additional threshold and trend and outlier configuration options in MLWeb to remove data outside of certain deltas. And also in the newer versions of MLWeb 2019, we also have the dynamic baseline option. So basically that looks at a given number of previous recordings and then dynamically adjust the data. So yes, you can have your data pretty clean.
Great, thank you. Next one is, what is the cost of a single unit? And if possible, and additionally, is there a cost reduction if a larger quantity is ordered?
Yeah, absolutely. So that's another advantage of the system. It's compared to some of the other systems in the market, it is fairly inexpensive. At least to my knowledge, you can buy like 3 systems from some of our competitors. Sorry, you can buy 3 of ours compared to 1 of our competitors. So the cost for a single station unit, which means you have 1 antenna to connect it to a base or rover, is roughly in the $4,000 range. That's the complete cost for the whole turnkey package. So everything that you saw, antennas and enclosures and everything in their radios, it's all included in that. We also have a 3-station system. So if you have the need to have 3 antennas in fairly close proximity, you can have just 1 station that connects to all 3, and the cost for that is $10,000. And we also have a portable version, I should mention, which comes with a tripod type setup and a Pelican case that can be deployed obviously very quickly, like here. And so this is great if you have concerns about movements. You can deploy one of these, have it average, over 24 hours roughly, you start getting a continuous stream of pretty accurate data. You do need 1 base as well, though.
Great, thank you. Next one we have is there a way to configure the communications to travel via internet, or is it local area network via Wi-Fi or Ethernet the only option? Dave, do you mind answering that one?
So we can put a cell modem on connected to these units, and that would be on the
public internet. So I think that would answer that question.
Great, thank you. Let's see. Next one we have is it possible to visualize data in space rather than as temporal, which was shown earlier?
Oh yeah, absolutely. This was just one. This was just one chart type. This was the basic time series charts. Can you switch back to MLWeb? Maybe we have. I think we have a couple more examples. We have a one of the drift plots. Maybe can you open one of the rover one drift plot? Nope, at the bottom. Further down. Further down. Right there. Yes. So this is a representation of station drift with northing versus easting. So we have a whole range of charting options in MLWeb that can be used to display various types of data, be it spatial or temporal or many others.
Great, thank you. Next one we have is the Novatel antenna the only antenna that works with the system?
No, we support others. We have, I believe we have, Dave, correct me if I'm wrong, I believe we have 2 or 3 coded in the system that you can select from a drop-down to get precise corrections for the antenna type, because the actual receiver sometimes is in a different location in the antenna. So you can get maybe better data with some of those that we support directly, but you can connect any, at least to my knowledge, you can connect any antenna or rover that you might already have.
Great, thank you, Martin. So we're just going to answer a few more. We do have several more to go through. We're going to answer those individually by email for some, or also include the answers in the email after the webinar goes live online, just to make sure everyone gets out of here on time. So the next question we have is, can you buy the system to use with a different data management system? So say you want to use MLGPS, but not necessarily Multilogger or MLWeb.
The short answer is essentially yes. You do want to have probably the multilogger component of this for the data collection and solutions processing side. I would certainly recommend that. But once you have that, you can, in theory, push the data into other systems. We also sell the stations as turnkey, but also as a module. So you can buy just the MLGPS board unit that you saw without the enclosure and the other hardware, and build that into your own system, or even resell. We do have reseller pricing as well. So in short, yes. I don't know why you would want to do this, given our MLWeb being able to visualize and do a lot of other things, but yes, it's possible.
Great, thank you, Martin. Next one is a projection required during setup for GPS data accuracy? Martin or Dave, do you want to answer that?
I don't know. Go ahead, Martin.
Well, if I understand this question correctly, so during the setup, you have the option to configure and determine what coordinate system you are capturing. You can define a projected system, but you can also use essentially just a local offset of the base station as well. So you have a number of options to set this up. I hope I understand the question correctly with projection.
Great, thank you. The next one is this system compatible with the older model SAAV instruments, say from 2017?
I guess that's not a GPS question, but yes, our software is compatible with the SAAV older models, yes.
Okay, I don't see any more questions. So I think we actually got through to them all. If we did miss one, we'll be reviewing these just to make sure that we got it back to everyone, either individually or through the questions at the end. You can continue sending us questions through info@canarysystems.com. We'll be happy to answer them there. And we'll also be sending out a recording of the webinar once this is all set for those of you who joined us and want to share it, or for anyone who might have missed it. So thanks again, and have a great rest of your day.